Hello, my dearest pre-cal babies. Okay, we are starting Unit 5. It's the best unit in the whole world. It's my favorite. Intro to trig and the unit circle. The unit circle is so much fun. You're going to love it. And in order to understand it, we have to revisit special right triangles. Now, I already did a video on right triangle review, but now we're going to get more specific and talk about special right triangles. There are two kinds of special right triangles. One kind has a 30-degree angle and a 60-degree angle, and the other kind has two 45-degree angles. So we're going to just talk a little bit about these. All right, so when we look at a special right triangle, there are specific rules we can always follow to find the measures of the sides. We don't have to use the Pythagorean theorem. We already know that because these are special, they have 30-60 right triangle here and a 45-45 right triangle. There are specific rules that are always true. For instance, if I'm looking at a 30-60 right triangle, if my hypotenuse measures 1, then the short side, and that is going to be across from the smallest angle. So the smallest angle has the side opposite as the shortest side. That is going to be half of the hypotenuse all the time. So half of the hypotenuse. So if your hypotenuse is 6, your short side is going to be 3. If your hypotenuse is 10, your short side is going to be 5, etc., etc. Okay, the other side, the side across from the 60-degree angle, that one's a little trickier. It is the short side times the square root of 3. So since the short side here is 1/2, it would be radical 3 over 2. So anytime you're looking at a special right triangle that's a 30-60 right triangle, whatever the hypotenuse measures, the short side is half of it, and the other side is going to be the short side times the square root of 3, no matter what. So if we're looking at this one over here, it is also a 30-60 right triangle, but it's in a little bit different position. It's just turned around, so the 30-degree angle's up here. So now this is the short side, the side across from 30, so I'm just going to let that be 1/2 since my hypotenuse is 1. And then my other side, the other leg of my right triangle, is going to be radical 3 over 2, or radical 3 times 1/2. All right, so what are the rules for a 45-45 right triangle? Well, a 45-45 right triangle, if you'll recall from geometry, that means that both of these legs of my right triangle are congruent to one another. So that means they're always going to be the same measure. So how do we figure out what that is? Well, if I'm looking at 1 as my hypotenuse, then my legs are going to measure radical 2 over 2. Okay, and y'all are like, Miss Griggs, where'd you get this craziness? Well, it always works. Let me tell you why. If I've got the Pythagorean Theorem, okay, I know that the Pythagorean Theorem is always a squared, if I could get my pen to work, a squared plus b squared equals c squared all the time. C is always the hypotenuse. So in this particular case, if my hypotenuse is a 1, then I've got 1 squared here. And if this is side A and this is side B, if they're the same things, then technically I've got a squared plus a squared, right? So that means that I've really got 2a squared equals 1. And then when I divide both sides by 2, I get a squared equals 1/2. And then I take the square root of both sides, and I get a equals the square root of 1/2. Well, if I look at this, it's actually the square root of 1 over the square root of 2, and I have to rationalize the denominator. So guess what you get? Radical 2 over 2. It always works, okay? So you're welcome. I know you're excited. Okay, so having said all that, Miss Griggs, why is this important? Well, it's not really important right now, but it will be when we get to the unit circle, because the unit circle is based on all of your triangles formed within a unit circle having a hypotenuse of 1. That's why we're reviewing special right triangles.